Hello students, today we start with current electricity. Current is the flow of charges through any cross section of a conductor per unit time. So current is charge upon time, NE upon T. For the current we have the two directions, conventional current, electric current. Conventional means for the heat flow, we say that heat is flow from higher temperature to lower temperature, higher to lower. This is the convention. For the water flow, higher pressure to lower pressure. Similarly, for the current flow, charge flow, it should be from higher potential to lower potential, and that is called the conventional current, positive to negative. But actually current is the flow of electrons, and electrons are the negative, so they must be flow from negative to positive. That is called electric current. Either we consider the two directions of current, but it is a scalar quantity because ordinary algebra law is used on this current to add it, not the vector algebra. SI unit is ampere. How we define 1 ampere? That is 1 coulomb charge 1 second. That is ampere is coulomb per second. Types of current. Study direct current. Direct means DC direct current whose magnitude and direction do not change. That is called study direct current. Variable direct current whose magnitude changes but polarity remains same. What do you mean by this polarity? Positive, negative, positive, negative. But here it is only in one polarity, but its magnitude is variable. Alternate current AC whose magnitude and polarity both are reverses periodically, that is called alternate current. But here in this unit we deal with only the steady current, direct current. Now how the electric charges flow in a conductor? We know that conductor have the free electrons and they are moving randomly here and there, so they cancel the effect of each other due to the random motion. Their random velocity, their thermal velocities average is 0 and they don't show any flow of charges. But when this conductor is attached with a battery, voltage V of length L, this voltage upon length give the electric field, and this electric field give another velocity to move the electrons in a particular direction to constitute that current, and that additional velocity is called the drift velocity, defined as the average velocity free electrons get drifted. Either they have the thermal velocities, ਉਹਨਾਂ ਕੋਲੇ random motion ਆ, ਇੱਧਰ ਉੱਧਰ move ਕਰਦੇ ਨੇ, ਸਾਰੀਆਂ random velocities ਦਾ net 0 ਆ ਕਿਉਂਕਿ ਉਹ ਇੱਕ ਦੂਜੇ ਨੂੰ cancel ਕਰੀ ਜਾਂਦੇ ਨੇ. But when we apply this potential voltage across the length, there is electric field, and electric field give the force on the electron. This is negative charge, means field direction is positive to negative, but force direction is negative to positive. और a force एक acceleration produce कर दिंदी आ, that is E upon M, and this acceleration give the additional velocity and the electrons accelerate, but this lasts for the short time because when the electron flow in the conductor, this flow is not a smooth flow. There is a collision between the ions, positive ions, walls of the conductor. Then this acceleration is for a short time and the again made 0 when it collide, and this time is called the relaxation time. So when the electrons, they have the random velocity, this u1, accelerate for time tau. We considering the tau as a vector quantity, but in this chapter we considering it as a scalar, that is called the relaxation time. So we have the formula V is equal to U plus AT. So जे number of electrons बहुत ज़्यादा ने, हर एक दियाँ ये thermal velocity है, पहला वाली velocity जेड़ियाँ electric field तो पहला ने, इन्हां दा net 0 है. तो जिवें additional velocity मिलनी है, तो each electron V1, U1, acceleration सब दा common आ, जेड़ा electric field ने provide कीता, that is tau 1. And if we form in a vector, then V2, that is U2 plus A tau 2, and so on. and the average of these additional velocities for all the electrons is called the drift velocity. So we put the value v1, v2, vn, n, and we're considering it. A common, this is 0 because this is the average thermal velocity due to the room temperature, due to the thermal temperature of the motion of electrons, and this is called the average relaxation time. So what we got, this is called the drift velocity, very important. Then it become this, and what is the acceleration? We use this value minus em tau, and negative means the drift velocity is opposite to the direction of electric field. Remember this. If this is a conductor and when it applied the potential V length, what is the direction of electric field? Positive to negative. And what is the direction of drift velocity? That is opposite to the electric field. So what is the drift velocity? E, charge of electron, electric field, mass, and relaxation time, average relaxation time, and this is the magnitude of drift velocity. Next is the relation between drift velocity and electric current. Very, very important result. Here we define the new term, that is N. N is called number density or number of free electrons per unit volume. Remember this, number density or the number of free electrons per unit volume. To explain this, conductor of length L, uniform cross section A, then what's the volume? AL. N is the number of electrons per unit volume. So total की हो जाएंगे, इनु volume ना multiply करता. जे इकते charge E है, then what about the total charge? This one is the total charge. Now, this is applied potential difference, this is electric field, and this is the drift velocity. Then how we get the time taken? Because electron ने सारी length drift velocity नाल ही cover करनी है. So the total charge is this one, and the time is length distance upon drift velocity, and the current is charge upon time. This is NALE. L upon drift velocity cancel, and we got the relation NAE, drift velocity. Very important relation, very important. Now put the value of this drift velocity, we get the next relation. And then we have the new term that is called electron mobility. Very important term, electron mobility. छोटियां terms ने chapter but बहुत important ने. This is mobility. This is drift velocity upon electric field. Drift velocity upon electric field. And you have this drift velocity. Put the value, you got the new value of this. This is called electron mobility. Many other forms, if we write drift velocity mu E multiply कर दिए और उन्होंने इस equation च put कर दिए तो फिर जेडी mobility आ वो current दे नाल की होगी relate होगी. This is the relation. Now we have the SI unit for this electron mobility. How we get the SI unit? This is, what is the mobility? Drift velocity upon electric field. So this is velocity the unit, एक the electric field the unit, and you have got this formulas. This is SI unit, and this is how to write the dimensional formula. And the next is current density. Current density, another term, very important term. We consider that the current is a scalar quantity. Either it has the two directions, conventional or electric current, but it is a scalar quantity. Now this is the new term called the current density. This is the amount of current passing per unit area of the conductor perpendicular to the flow of charges. In simple form, we can say that current density किया current nu vector form च लिखन दा तरीका, that is called current density, denoted by J. How you define? Current upon area. Now current is a scalar, this is a vector, and we considering area vector जो Gauss theorem च पढ़िया सी असी flux दे विच. So how you say? You say that current is the dot product of current density and area vector. These are the other forms. You must remember these forms. Current density is current upon area. Current लिखो, जो रिलेशन आ एरिया लिखो. This is the relation between drift velocity, current density. And if we put the drift velocity E tau m is which put karange, then we get the new form of current density. So in this chapter we have a number of formulas which are related with each other. And the next is Ohm's law. 10th ਦਾ ਟੌਪਿਕ ਆ ਪੜ੍ਹਿਆ ਹੋਇਆ ਤੁਸੀਂ ਫੰਡਾਮੈਂਟਲ ਲਾ ਆਫ ਇਲੈਕਟ੍ਰਿਸਿਟੀ. ਕਰੰਟ ਫਲੋਇੰਗ ਤੇ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ ਡਾਇਰੈਕਟਲੀ ਪ੍ਰਪੋਰਸ਼ਨਲ ਨੇ, ਬਟ ਕੁਛ ਕੰਡੀਸ਼ਨਸ ਨੇ ਜਿਨ੍ਹਾਂ ਦੇ ਅੰਡਰ ਕੀ ਆ ਇਹ, ਜਿਵੇਂ ਟੈਂਪਰੇਚਰ, ਪ੍ਰੈਸ਼ਰ, ਸਟ੍ਰੇਨ, ਦੇ ਆਰ ਰਿਮੇਨ ਅਨਚੇਂਜਡ. ਸੋ ਵੀ ਡਿਫਾਈਨ V ਇਜ਼ ਇਕੁਅਲ ਟੂ IR, ਵੇਅਰ R ਇਜ਼ ਦਾ ਕੌਂਸਟੈਂਟ ਕਹਿ ਸਕਦੇ ਹੋ ਤੁਸੀਂ, ਪ੍ਰਪੋਰਸ਼ਨਲ ਕੌਂਸਟੈਂਟ ਜਿਹਨੂੰ ਰੈਜ਼ਿਸਟੈਂਸ ਕਿਹਾ ਜਾਂਦਾ. ਔਰ ਇਹਦੀ ਵੈਲਿਊ ਨੇਚਰ ਆਫ ਮਟੀਰੀਅਲ, ਡਾਇਮੈਂਸ਼ਨ ਤੇ ਟੈਂਪਰੇਚਰ ਤੇ ਡਿਪੈਂਡ ਕਰਦੀ ਆ, ਬਟ ਨਾਟ ਔਨ V ਐਂਡ I. ਜਸਟ ਰਿਮੈਂਬਰ ਦਿਸ, ਨਾਟ ਔਨ V ਐਂਡ I. ਓਕੇ.